Okay, I'm going to start introducing section 5.5 in Algebra 2 Honors. It's addition and subtraction of rational expressions. We're going to assign 5, 5, 3 to 35 odds, but let's do some examples to make sure everybody's comfortable. To add or subtract fractions, you need common denominator, like 4x and 4x are already common denominators. So you have 4x, basically you just add your numerators. So that becomes 10 over 4x. You could do half of 10 and half of 4x. Basically, factor out a 2 at the top, factor a 2 out of the bottom, and cancel. So the answer would be 5 over 2x. Now, in B, you'll notice they also have a common denominator of x plus 6. They're both over it, so all you have to do is combine your numerators. So you get 2x minus 5 over x plus 6. Finding the least common multiple can help you find common denominators. So let's see if you can do these. We need to be able to factor. Can I take a 4 out of these? That would leave me with x squared minus 4, right? How does 4 factor? 2 squared. How does the x squared minus 4 factor? Well, it's a difference of squares. X plus 2 times x minus 2. And over here we want to factor it. Can I take a 6 out of all these? That would give me x squared minus 4x plus 4. How would that factor? 6 factors into 2 times 3, doesn't it? 2 times 3. This is going to factor into x minus 2 times x minus 2. So I want to stop a moment, make sure everybody's okay with the factoring between these two things here. We want to take the highest, now that we have them factored, we want to take the highest power of each factor. What's the highest power of 2? I see a 2 to the first and a 2 to the second. So that's my highest power of 2. What's the highest power of 3? 3 to the first. What's the highest power of x plus 2? Well, that's only raised to the first. What's the highest power of x minus 2? Well, I see that one is to the second. And that is my least common multiple. 4 times 3, I think the book's going to call it 12 times x plus 2 times x minus 2 quantity squared. Once again, you factor it completely and then take the highest power of each factor. I was just asked an excellent question. I was asked what happened, what about this x minus 2 here? Well, this is x minus 2 to the first, and this is x minus 2 to the second. I only want to take the highest power, so that's why I only used that. So I did not use it to the first because I had one that was to the second. If I had one to the fifth, I would have used it. You want to take the highest power. Okay, we're going to move on a little bit, try some more examples. Here we have to get a common denominator. So let's do this. 9, I'm going to factor that. 9 is 3 squared and x squared. How can I factor over on the right the denominator? Looks like I could take a 3x out and an x plus 1. Any problems in factoring the denominator? Okay, let's find the least common multiple. We want the least common multiple, so I take the highest power of each one. What's the highest power of 3 that you see? 3 to the 2 or 3 to the 1? 3 to the 2 is a bigger power, right? Okay, how about x to the first or x to the second? Which is a higher power? X to the second. Here you have an x plus 1 to the first. Over here you don't know it, but you have an x plus 1 to the 0. Anything to the 0 power is 1. So which is bigger? The 1 or the 0? The 1. So really, I'm just going to use the x plus 1 to the first. So what is this? This is 9x squared times x plus 1, right? And that's your least common multiple, but it's also going to be your common denominator. So I want to make my common denominator 9x squared times x plus 1. You already have the 9x squared. What do you need to make the denominator? Any ideas? You have the 9x squared. You need the x plus 1. Would that give me what I wanted on the bottom? I think it would, right? Now, over here on the right, you have this. How do I make it into a 9x squared? You have the x plus 1. How do you make 9x squared? What's 3x times 3x? 9x squared. So would this be a fancy form of 1 so that I don't change the value? And what do you get on top? 3x squared. So now all I have to do is simplify the numerator. Standard form is decreasing powers. 3x squared plus 7x plus 7. And this is divided by 9x squared times x plus 1. Now, if the numerator factored, I would factor it, but I don't think there are factors of 21 that add to 7. So I do not believe the numerator factors. Always leave your denominator factored. Always leave I like it all factored form. Okay, let's try example 4. I need a common denominator. Before I do that, I need to factor everything. So hopefully you'll pay attention. If you factor a 2 out of the bottom, you get x minus 1. Can I take a negative out of these ones on top? What would that make it then? 2x plus 1. And how's the denominator factor? Factors of 3 that add to negative 4. Negative 3 and negative 1. So I have everything factored. Now, what I'm going to do is I'm going to take these two minuses right here and make it a plus. And I'm going to get a common denominator. What's the biggest power of 2 that you see? 2 to the 0 or 2 to the 1? Well, 2 to the 1 is bigger, so that's going to be part of it. X minus 1 I see to the first. X minus 3 I see to the first. So this is my common denominator. Any problems with that first? I have this in my denominator. What am I missing? I'm missing the x minus 3. So I'll multiply it by x minus 3 over itself to not change the value. Does this now match the denominator? Yes? Okay. On the right, I have, yellow won't work on this one. How about on the bottom, I have x minus 3 and x minus 1. So I have these. What don't you have? The 2. So you're going to multiply by a fancy form of 1 that will make a 2 on the bottom. So what do I have on the left? In purple, could I call this x squared minus x minus 6? On the right, in blue, could I call this 4x plus 2? 4x plus 2. X squared plus 2x minus 3x makes this negative x. And then last times last is negative 6. Anyway, we just want to clean the numerator up now. So what does this give me? X squared, negative x and 4x add to combine to give me a 3x. Negative 6 and 2 combine to negative 4. Does that factor? X plus 4 and x minus 1. How about over here on the bottom? We have a 2, an x minus 1, and an x minus 3. 2, an x minus 1, and an x minus 3. Will anything divide out to simplify? I believe the x minus 1's could cancel, right? So let's see if I can do this with the highlighter. The x minus 1 will cancel with the x minus 1. And my final result is x plus 4 over 2 times x minus 3. Hopefully you see the same result in the textbook up on the screen. I've taught math a long time. I think I've taught every math course offered in Broward County over the last 30-some years. So I teach, no matter what I teach math-wise, I always teach it using inverse operations. So for a very basic example, 3x squared minus 1 equals, let's say, 11. I always say, what's the opposite or inverse? You want to isolate the variable. So what's the opposite or inverse of subtracting 1? Adding 1. So that gives me 3x squared equals 12. I'm going to write that twice because I'm going to do it two different ways. 3x squared equals 12. Anyway, opposite of multiplying by 3 is to divide by 3. That gives me x squared equals 4. What's the inverse or opposite of squaring? Square rooting. That's why they're on the same key on your calculator. And if you square root 4, you get 2. But if you take a square root in an equation, you have to put plus or minus. The real reason is, suppose you subtracted. How would this factor? Would this factor to x plus 2, x minus 2? So the two things that make this equal 0 would be 2 and negative 2. But every math I do is inverse operations. What I really need you to know is, what's the opposite of dividing? Multiplying. So what I'm going to do is, this is called a complex fraction. I will never accept an answer as a complex fraction in any math course I've ever taught. So if you're given something like this, you need to simplify it. So you're going to use what's called the common denominator. The common denominator is going to be the highest power of everything that you see. So what is the highest power of x that I see? X to the first. How about x plus 4? Do I have that to the first also? This confuses a lot of people. Please try to stay with me. When I multiply on top, this is a fancy form of 1, so I'm not changing its value. Will the x plus 4's cancel? Yes. Leaving me what on top? 5 times x, right? The only two things that aren't canceled. When I multiply on bottom, please watch. Here what cancels? The x plus 4 with the x plus 4, and what's left? X. Now you still have this x plus 4 here. Now when I multiply here, what's going to cancel? The x's, leaving me 2 times x plus 4. So my answer is going to be 5x over x plus 2x plus 8. Simplify the denominator. 1x plus 2x is 3x. And now you do not have a complex fraction. The trick is to multiply the top and the bottom by the common denominator. This will take some practice to get comfortable with.